Okay, now I think we're getting into the bigger questions, 5 marks, 4 marks, yeah, much bigger questions now. I think this has been a reasonably straightforward paper, and this is probably the first of the big ones, yeah. So integration, isn't it? We've got an area between two curves. The minute you see a shaded area on a graph, you should be thinking to yourself, integration. Okay. Quick word about integration. We would do these separately. Say I had a curve like this. Okay. This would give me a positive area, and this would give me a negative area. Therefore, you do not integrate between above and below the line at the same time. I would do this area separate to this area. So if this came out as +3 and this came out as -1, I would say the total area is 4 because that's an area of 3 and that's an area of 1. When you're going between the curves, you don't have to worry about that. You can go above and between the lines. Okay, and again, you're using these limits here. So I've got a limit of 2 to 0. In this case, say I had 4 and 0 and 5. I'd be integrating between 4 and 0, separate to 5 and 4. And you always integrate from the highest number to the bottom, the lowest number. So, so yeah, just a little bit about that. So you go from your graph to the axis unless you're doing what we're going to do, which is upper take away lower. So if I just integrate, say I was to say I'm going to integrate, and I'll just write x cubed take away 4x squared plus 3x plus 1. If I say I'm going to integrate that function, so that's this one, between, say that was 1 and 0, it would work out everything from the x-axis up to the function. Okay. But I don't want that. I want the area between these two curves. And all we have to do, actually, plus 1, all we have to do is take this function, our top function. So I've done that one in red. Yeah, that's our red one. All we have to do is take that up and take away from that the lower curve, and then it works out the area between the two curves, which is pretty neat actually when you think about it. So I'm going to take away from that x squared, take away 3x plus 1. And I'm going to integrate them between 2 and 0. Now you always want the top number, the highest number at the top, absolutely. And I have lost a little mark. Can you spot the mark I have lost? I've not said dx. I'm integrating with respect to x. Okay, so that is actually quite a tough maneuver just to get everything in line. Don't forget your dx. Get your limits, which is all on the x-axis, from where, well, that's the shaded area from where they meet. They've helped you out there. And make sure it's all in a bracket as well. Otherwise, this takeaway, you're only going to take away the first term. You want to take away all these terms, so it all has to be in a bracket. Okay, so that's quite a hard move to start off with. So 2, 0. I'm going to keep my dx. I'll just put it over there, just to remind me. You can start off with that if you want. And let's see. So I'm going to have x cubed. That's fine. Now here I've got negative 4x squared. I'm taking away another one, so I'm going to have negative 5x squared. I've got 3x, and I'm adding on 3x, so I'll have 6x, and I've got 1, taking away 1, so I've got no units. Okay, so that's me. I'll maybe just move him over a bit messy, doesn't it? So that's me, ready now to integrate. How do you integrate? Well, let's remember, x squared, if I differentiate, becomes 2x, so if I integrate it becomes x squared. And that's because I'm adding 1 on to the power. So I'm adding 1 on, and then I'm dividing by that new power. Yeah? So add 1 onto your power and divide by the new power. So on the next line, this now becomes my box, because I'll have integrated it. So add 1 onto the power, so x to the 4, and divide by the new power. Yeah? Add 1 onto the power and divide by the new power. Add 1 onto the power, divide by the new power, so 6 divided by 2 will give me 3. So just take your time with that, take your time. And after that, we're going to substitute. So I'm going to say that I've got 2 to the power of 4 over 4, take away 5. And again, put these numbers in brackets if you're doing a substitution and there's a coefficient. Otherwise, you might make a little mistake. And to that I'm going to take away, and thankfully they've just given us a nice big 0 there. That's excellent. That would be 0, take away 0, brilliant. Saves me some work. And now it's on to you just to do a little bit of arithmetic, which is very easy to make a mistake. Let's just take your time. So, 2 times 2 times 2 times 2 divided by 4. So that's going to come out as 4. Take away, that'll be 40 thirds. And that's going to be 4 and 12. There we go. So let's add all that together then. What's the best way to do that? How about I add my numbers together? So that's the same as saying 16 take away 40 over 3, isn't it? And then if I put that all into thirds, that's 48 thirds take away 40 thirds. And that's going to then give me 8 thirds. Now each time I'm taking away 0, I'm taking away the 0, taking away, I've kind of forgotten about that, but yep. And that's units squared. So this bit, quite a bit of work in there, but not hard though, just taking your time going through it. This bit's the technical bit. So let's just see the marking scheme and see what they're going to give us for all of this, because there's some good points available. Let's have a look. Question 10. Okay, so you're going to get a mark, I'll do this in green, for knowing your limits in dx. So right away, limits in dx was 1. Doing the upper and lower was another mark. The actual integration was worth a mark. Substitution was worth a mark. And then your final answer was worth a mark. So look at all that. Look at all that work in here, playing about with negatives and fractions and stuff. So not a lot in there, but look at that. 1, 2, 3, 4. It's all happening up here. Yeah, 4 out of 5 for taking your time, dx, limits, etc. Yeah, so excellent question. Just to, if you can take your time and go through it all. Part B looks like it's going to be quite similar actually. So now they've drawn a big line through here. Okay, determine the fraction of the shaded area which lies below the line. Okay, so we're going to compare this area to the whole area. So really this question is saying calculate this area, and then we'll compare it to the top one. So I'm not wild on time, so I'm gonna just pause it and I'll do my lines of work in a wee bit quicker. Hey, by magic. So the upper line is the straight line this time, and the lower line is this curve here. So I've done upper take away lower. Remember your limits are still the same and dx is still there. And now I'm ready to integrate. So I'm going to do my box between 2 and 0. So add 1 onto your power, divide by the new power. Add 1 onto your power, divide by the new power, so it just becomes a 1, doesn't it? And then I'm going to substitute in my limits. So this time, much similar to last time where we've got the 0, so -2. Now, get that 2 in the bracket. The negative does not belong inside that bracket. That's a classic mistake to make, okay? So watch out for that, and that's take away 0. So if you do that, run out of space here, I will move up to there. Should end up with, let's have a look, -8 over 3. Yep, because it's going to become negative plus the 4. Excellent. So that's -8 thirds plus 12 thirds. Oh, my brain's getting sore. And that's 4 thirds units squared. Okay, so that's most of the question done, but it wants the fraction, doesn't it? It wants the relationship between this and the other. So we're saying that's 4 thirds, and we said the whole thing was 8 thirds. So this has got 4 thirds, and the whole thing's got 8 thirds. Oops, not 3, 8 thirds. So 4 compared to 8, this is half the area, isn't it? Yeah, so I'd say therefore it's half the area. Nice, so not bad little question. You're getting really the same marks for doing the same skill, so that's quite nice. And we'll just check the marking scheme. If I get cut off, don't worry, you've not really missed anything much. Part B. So yeah, you're getting your mark for your upper and lower again, for your integration, for your substitution, and then your final answer. So again, a lot of good marks early on. So get your equation correct, upper take away lower. Don't forget these brackets. Don't forget the dx. And just take your time. Add 1 to the power and divide. And honestly, nice, neat work in taking your time will pay dividends. Alright, hope that's helpful.